I'm Anil Kumar. Welcome to my series on calculus. We'll begin with prerequisite skills. I have a set of 10 questions here which will help you getting started with calculus. Calculus is all about finding equation of a tangent line and to work with the curves. So all these questions are directed so that you could be absolutely ready to start with calculus without any problems. Let me first share with you all the 10 questions and then one by one we'll take their solution. Question number 1. A linear function is given by x plus 2y equals to 1. How does y changes if x is increased by 6? All are multiple choice questions. You will be given 4 choices. You can select the best one. Question number 2. Equivalent expression for 2x to the power of 7 over 2 minus 2x to the power of half is what? So here we are testing your factoring skills and to work with rational exponents. So many students find it difficult to work with rational exponents. It is good time to review and get ready for calculus. And this question is really going to help you. Question number 3. Equivalent expression for square root of x square plus x minus square root of x square minus x is 4 choices. Now this is based on rationalization. You need to rationalize the given expression to find equivalent expression. Question number 4. Equation of a tangent line to the parabola y equals to x square at the point 1, 1 is what? So here, rate of change. Now rate of change is a very important concept which you have learned in functions and it's going to be very useful as you solve questions related to calculus. Question number 5. Find the point on the curve y equals to 3x squared minus 4x where the tangent is parallel to the line 8x minus 5 equals to 0. This question is based on similar concepts as question number 4, but this is a very important topic. Half of the calculus depends on working with the curves, finding tangents. So we have taken 2 questions on this topic. Question number 6. Graph of the function y equals to 1 minus square root of 2x plus 6 is what? Based on transformations, you need to confirm which is the right graph for the given function. I hope that makes sense, right? So now let's move on to question number 7. The equation sin 2x cos 2x equals to 0 will have how many solutions in the domain 0 to 2 pi? So we are not asking for the solutions, we are asking for number of solutions. So get ready with double angle formulas. Trigonometry is a huge part. So you may have to review most of your compound angle formulas to get ready for calculus. Question number 8. Find the slope of tangent line at the point 0, 1 for the functions y equals to 2 times x minus 1. So you may do this using the graph. That should help you to quickly get the answer. Question number 9. Equation of the tangent line to the graph x square plus y square equals to 25 at 3, 4 is what? So another question based on equation of a tangent line. So now you can feel the importance. So go through this topic of rate of change, instantaneous rate of change, and that should prepare you for calculus. The last question here is we are given a piecewise function f of x equals to kx minus 2 where x is less than or equal to 3 and f of x equals to x squared plus 1 when x is greater than 3. For what value of k can f of x be continuous? 4 choices are again given to you. So that is a piecewise function. So I hope you get a good overview of what you should be working on to begin with calculus, right? So this is, of course, not a complete list, but definitely these are one of the most important topics which you should consider when you are starting with calculus. So as we solve, I will take time to explain you concepts, kind of review the concepts so that you're almost ready for calculus by the end of this video. I'm also going to take a small break to enjoy the Canadian winter and the wildlife here in the city of Toronto. So let's begin with question number 1. Question number 1. A linear function is given by x plus 2y equals to 1. How does y change if x is increased by 6? So what we are given here is x plus 2y equals to 1. Now let's isolate y. So we get 2y equals to minus x plus 1, and y will be equal to minus half x plus half, right? So from here, what do you notice? You notice that slope of this line is what? Is equal to minus half. Now slope really means rate of change, right? So it means change in y over change in x is minus half, correct? So when we say increase, x is increased by 6, that really means what? That means delta x is 6 and we need to find what delta y is. So I hope that gives you the concept, right? So it's a straightforward question, but the concept is very important. So we'll just rewrite this and say minus half is equal to change in y over change in x is 6 for us. So cross multiply, so we get minus 6 over 2 is the change in y, and that is equal to minus 3. So minus means decrease, right? So option C is the right option. So it is decreased by 3. Does make sense to you? So that is how we need to answer. Question number 2. Equivalent expression for 2x to the power of 7 over 2 minus 2 times x to the power of half. Now we need to factor this. So 2 of course is a common factor. So let's rewrite first. So we have 2x to the power of 7 over 2 minus 2 times x to the power of half, right? So first thing, let's factor out 2. So if you factor out 2, we get x to the power of 7 over 2 minus x to the power of half. Now how do we work with the rational exponents? You need to check which one is smaller. You only factor the one which is smaller, right? So x to the power of half is smaller. It could be taken outside as a common factor. So we'll write 2 times x to the power of half. Now when you factor this out, we have to divide each by x to the power of half. Dividing means take away the exponents, right? So it becomes x to the power of 7 over 2 minus half, correct? Minus, we have taken out this as a common factor, so we get minus 1. Now what is that equal to? X to the power of half is actually square root x. So we have got the first two terms. I should say the first term. And here 7 minus 1 is 6. 6 divided by 2 is 3. So we get x cube minus 1. Is that clear? Now a cube minus b cube formula, I think you should remember. Very important formula. So we'll apply this. I'm writing this as square root 2 since it is given in that form. And this is x minus 1 times a square plus ab plus b square. X square plus ab is x plus 1, correct? So that is how you need to factor. So the option which matches is the very first one, so option A. So what you need to remember here is the formula, of course how to work with radical exponents, and also you need to remember what is a cube minus b cube equal to, right? So it is a minus b times a square plus ab plus b square, correct? If we have a cube plus b cube, in that case the signs will change at these places as shown here. So I hope that makes sense, right? So that is how you have to answer this particular question. Now let's take the next question, which is question number 3. we need to find equivalent expression for square root of x squared plus x minus square root of x squared minus x. So those are the choices. We actually rationalize numerator here. Rationalization is a very important part. You should be really good at it. So how do we rationalize? So we have this expression which is x squared plus x minus square root of x squared minus x. It could be written as divided by 1. So that is how we are treating this as a rational type of a thing, right? P over Q. Not really a rational function because square root. Rationalization means multiply and divide by the conjugate. Now conjugate of this is x squared plus x square root plus square root of x squared minus x. Correct? So we are going to multiply and divide by the conjugate of the numerator. So we get this, right? Now, when you do that, we get a square minus b square in the numerator. That is to say, x square plus x whole square means the square root vanishes, minus x square minus x. And in the denominator, we get 1 times this, which is square root of x square plus x minus, oh sorry, this was, this is minus, that's okay. We are doing this one. Okay, so plus square root of x square plus x. Perfect. Now clearly you can see in the numerator x square minus x square is 0, but x minus x is 2x, right? So you can now simplify and you get 2x over square root of x square plus x plus square root of x square, I'm sorry, this was minus x, correct? So that is what you get, which matches with your option D, correct? So here we rationalize the numerator to find the answer. Now this is a very important part of calculus and you should practice with more rationalization. You can also watch some of my videos on rationalization. I'll provide you a link for those. Perfect. Let's take a small break and then we'll continue with rest of the questions. Question number 4. Equation of a tangent line to the parabola y equals to x squared at point P, 1, 1 is what? Now let's try to understand the basic concept, right? So, and then we'll actually provide you with the solution, right? So this is my parabola y equals to x squared. It is symmetric about y-axis. And when we are saying equation of the tangent line at a given point, in this case the point is 1, 1. So let's say this is our point, right? So, and this point here is 1, 1, right? So we have to find equation of this line. How do we do that? That is what we'll try to see, correct? So on a curve, this to find the rate of change, the instantaneous rate of change, we can consider a point Q on the parabola, which is very close to P, right? So if it is very, very close, let us say that h distance away, in that case, we can say that the slope, because Q is another point on the parabola, so we can say the point Q is slightly away from P, right? So let me provide you with the general solution. So I'll provide you with the general solution so that you could use that in any similar question. Is that okay? So I'll consider point P as xy and point Q as x plus h, right? So where h is very close to, so that h is very close to the point P. That's the whole idea, right? So if it is x plus h, then the value will be f of x plus h, which is, I could write this as x plus h whole square. Doesn't make sense to you, right? So if the x value is x plus h whole square will be the y value. Correct? So we can say the slope of this particular line, let's say m, will be equal to y2 minus y1 over x2 minus x1. Now, y2 is the point Q for us. So it is x plus h whole square minus x square over x plus h minus x. Is that clear to you? So simple as that. Now here, h is very small. So we say h is very, very small as compared to 1. Very close. Only then we get a tangent. Otherwise, we get a secant, right? So we're saying h is approaching 0 so that the secant approaches tangent. Correct? So secant is a line which cuts through two different points, right? Tangent is through one point, correct? Okay, so that is the concept. So let's expand this. We get x squared plus 2xh plus h squared. That is expanding x plus h minus x squared over the denominator here is only h, x and x cancels. So x squared minus x squared cancels. So we get 2xh plus h squared over h. So that gives you, we could write here, let me write here itself. Taking h common, so we get 2x plus h over h and h cancel. So we get this slope as equal to 2x plus h. Now since h is very small, right, since this is very small, we get this approximately equal to 2x. Does it, right, since h is very small. Is that okay? So we can approximate that to 2 times x. Now in our case, what is the value of x? Since x is equal to 1, right? So in our case, x is 1. So we have to have slope at the point 1, 1 is basically equals to 2 times 1, which is 2. Correct? So that becomes the slope. And now we can write down the equation of the line, right? So we know the slope, so we can write equation of the line in standard form like y minus y1 equals to m times x minus x1, correct? So y minus y1 is 1 for us. Slope is, we just found this to be 2, right? So it is 2 times x minus 1, correct? So we can just open, rearrange and get the answer. So we get y minus 1 equals to 2x minus 2. And that gives you the answer as, bringing them all together, we have 2x minus y, and this comes here. So we are given that form. Okay, so we'll bring 2 to this side. So we get 2x minus y equals to 1, right? So bringing 2 to the left makes it plus 2. So we get 1 here. And taking y to the other side, 2x minus y. So 2x minus y equals to 1 is the equation of our tangent line. So is that concept clear? Now this is a very important method and we'll soon call it a difference quotient method. So I'd like you to review few questions based on different kinds of functions. This strategy is going to be similar to what we did. If you choose square root function, you may have to rationalize. Perfect. Then you will get the correct solution. I hope it makes sense. Now let's move on and take another question for you, which is similar. The idea of taking this question here is that you get practice. I hope you got the concept, right? Now, keeping that concept in mind, I'd like you to pause the video and solve this question. Correct? Question number 5. Find the point on the curve y equals to 3x squared minus 4x where the tangent is parallel to the line 8x minus y. So when we say parallel to the line, that means the slope is same, right? So let's work out that. So this line 8x minus y equals to 0 means y equals to 8x means slope m is 8. Now in this particular question, we are given the slope, right? We have to find now the point on the curve where the slope is this. Perfect. So we can again use the same formula, which is m is equal to f of x plus h minus f of x over, when we do x plus h minus x, you get h only, right? Where h is approaching 0. Perfect. Very, very small. And we know that the slope is 8 for us, correct? So we know slope is 8 for us. So we'll write 8 equals to x plus h means replace x with x plus h. So we get here 3 times x plus h whole square minus 4 times x plus h, right? Minus f of x will mean the whole expression, which is 3x squared minus 4x divided by h. So that is what you are going to get. So I hope that is clear, right? So apply this concept, pause the video and answer. So now let me expand this and simplify to get the point, right? So we'll get the value of x. So I'm writing 8 and we'll expand this. We got 3 times x squared plus 2xh plus h squared. So that is first term minus 4 times minus 4x minus 4h. And here we have within brackets 3x squared minus 4x. Now all this is divided by h. As you can see, these two terms will cancel. Minus 3x squared with 3x squared and minus 4x with minus 4x, right? Negative of this. Now the remaining terms will have h common. Do you see that? H common, right? So let's rewrite the remaining terms. We get 8 equals to 3 times 2xh plus h squared. And here we have minus 4h over h. Perfect. So here I will take h common and let's rewrite by multiplying all this. Okay, let's take h common. See what do we get. So we get 6x plus 3h. We have taken one h common minus 4. Perfect. We have taken h common divided by h. Now this h cancels. So you have 3x plus 6h minus 4 and this is equal to what? Since h is approaching 0, this approaches 0. So we have 6x minus 4. Do you see that? Since h approaches 0. So we get 6x minus 4 equals to 8. So we have now the equation 8 equals to 6x minus 4. So bringing that together, we get 4 plus 8, which is 12 equals to 6x, and that gives you x as equals to 12 divided by 6, which is 2. Perfect. So if x is 2, what is y? That is what we need to find, correct? So we'll substitute 2 here and find the value of y. So y is equal to, well, it should be 4. Since we are given option B, which is just x is 2. So let's check. Let's put 2 here. So we get 3 times 2 squared minus 4 times 2, which is 4 times 3 is 12 minus 8, which is indeed 4. So we get y equals to 4. Correct? So the point here is 2, 4. Correct? So in this particular case, as you can see, we did kind of reverse operation. We knew what the slope is and we found the point on this parabola where the slope was 8, similar to or parallel to the line 8x minus 5. So I hope that is absolutely clear. Perfect. So with these two examples, you've seen how the difference quotient method can be effectively utilized to find slope of a tangent line on any curve. In calculus, we'll find much simpler ways to solve similar questions. Question number 6. Graph for the equation y equals to 1 minus square root of 2x plus 6 is what? So 4 different graphs are given to you. You need to figure out which one is the correct one. So that you need to review transformations, right? So if you look at it, basically we can write the function as y equals to minus square root of 2 common, right? So x plus 3 square root, and this is kind of 1, right? So as you can see here, the transformation basically is, this is a reflection on x-axis, right? So what we have here is reflection on x-axis, correct? First, as you move on, this is horizontally compressed by a factor of half, right? So this is compressed horizontally, compressed by factor of half, correct? And then translated 3 units left, horizontally, translated 3 units, 3 left, and we can say 1 up, correct? 3 left and 1 up. Now that is what it is. Now which of these graphs satisfy all these conditions, right? So some mistake which you could do is, if you don't factor 2 out, you will think it has translated 6 units left. So these two are 6 units left. They are wrong answers. Do you get the idea? They both are -6 and -6. So they are wrong, right? So this is -6 here. This is also -6. These two are at -3 and this point is -3. Correct? So these two are wrong. Now one of these is correct. Okay? So which one is correct? Since there is a reflection on the x-axis, we say A is the right option, right? So this graph is standard parabola is kind of like this, right? So it has been reflected on the x-axis and then moved left. So reflected on the x-axis, moved left 3 units, not 6, gives you the right answer. So that is a very important question for you to understand. So important thing here is always to factor this component so that you get the right solution. Perfect. Question number 7. The equation sine 2x cos 2x equals to 0 will have how many solutions in the domain 0 to 2 pi? 4 choices are given to you. Now this is again, you could solve using graphing. We don't really want you to find the solutions. We are interested in finding the number of solutions, right? So when we say how many, we are just finding number of solutions, right? I will show you the solution in 2 different ways. One, you could consider the equation given to you, which is sine 2x times cos 2x equals to 0. Now, for the solutions, either sine 2x is 0 or cos 2x is 0, right? So both are possible, correct? Now, when I say the interval for us is 0 to 2 pi, then sine 2x will be kind of like what? That means we have 2 waves in 0 to 2 pi, correct? So it will be one wave and the second wave. So that is in the interval of 0 to 2 pi, correct? For cos 2x, again, there will be 2 waves. So that is one wave and then the second wave, right? So this is 2 pi for us. How many zeros? So when you sketch this, clearly you can count the zeros. 1, 2, 3, 4, 5, 6, 7, 8 and 1, 9. So we get option C as the right option, right? So we didn't do much. We just equated each to 0, right? So sine 2x and cos 2x. Do you see that? And we found the solution. That is one way of doing it. Some of you could also do like this. Sine 2x times cos 2x could be written as, I could multiply by half times 2, right? We need to make it to 0. Now 2 sine 2x cos 2x is sine 4x. So we get half of sine 4x. You may have to review compound angle formulas for beginning with calculus. That is very important, right? So that really means that sine 4x should be equal to 0. Now when I say sine 4x, then again we'll sketch. Now for sine 4x within 0 to 2 pi, how many waves we'll have? We'll have 4 of them, correct? So for sine 4x, they will be like 1, 2, 3, and 4, right? So that gives you how many solutions? You can just count them. And these are 1, 2, 3, 4, 5, 6, 7, 8, and 1, 9. Do you see that? So we get the same answer. So whenever you have trigonometric equations given domain, you have to understand that this domain was given for x. So x was between 0 to 2 pi. 2x will be, you have to multiply them by 2, 0 to 4 pi. And 4x will be between, you have to multiply this by 4, right? So between 0 to 8 pi. And that is how we get our answer, correct? So I hope that gives you a good understanding of how trigonometry could be very useful, and sketching makes it much more simpler to solve questions. Let's move on and take question number 8 after a break. I hope you enjoyed the nature. We really had very severe winter with temperatures dipping down below -20 and a lot of snow. Well, still, there's a lot of wildlife here to enjoy. So let's continue with our questions. We'll do question number 8, 9, and 10. We have already done 2 related to the graph of function. Question number 8 here is, find the slope of the tangent line at the point 1, 0 for the function y equals to 2 times absolute value of x minus 1. Now we are going to solve this also using graph, right? So let us try to sketch the graph of this particular function. Y equals to vertically stretched by a factor of 2, absolute function moved 1 unit to the right. So let's say like this, right? So that becomes the function for us. To give you some points, if I write x equals to 0, I get 2, so this is 1. If I write x equals to 1, we get 0, right? So if I write x equals to 2, then I get a value 2. I'm sorry. So we get 0 at 1, and at 2, we again get 2 here, right? So the point of interest is the point 1, 0. So we are actually looking at this point, which is the x-intercept. So what is the slope of tangent line at this point? Now if you look at it from the left side, then it seems to be -1, right? So this side will give you slope of -1. This side gives you slope of +1. And x-axis, which is m equals to 0, can also give you a slope. Actually speaking, for an absolute function, any line here could be tangent at this point, right? So even a line which could be drawn like this is tangent to this absolute function. Perfect. So what we have here is so many choices. That really means the slope is undefined. We are not very certain about it. Perfect. So any cusp or a corner. So what we learned here is that at a corner, slope is undefined. Correct. So from a graph, if you have a corner, not a smooth curve, in that case the slope is undefined. So this is a very important concept which we are going to use in calculus. Now let's move on to question number 9. Equation of the tangent line to the given graph, which x square plus y square equals 25, is a circle, right? At 3, 4 is what? Okay, so let's understand the graph. Which is a circle in this case, and we are interested in finding slope of a tangent line at a point which is 3, 4. This is somewhere here, right? So it could be something like this. So that is what we are interested in finding. So it definitely has a negative slope, right? And this is the point which is 3, 4 for us. From the given choices, you could straight away get the solution also, right? But how do we find it? Let's try to understand that part. So if I join this point with the origin, in that case, we know that tangent is perpendicular to, let's call this point as P. And this is, so the slope M is basically perpendicular So I should say perpendicular to OP, right? So let's take another point on this. Let's say PQ, right? So slope of PQ is perpendicular to slope of OP. Does make sense, right? So you get what I'm saying. Let me rewrite. So slope of tangent PQ is negative reciprocal to the slope of OP, right? Since they are perpendicular, right? So what I'm trying to say here is that the radius 0 to O to P is perpendicular to the tangent PQ. So that really means if I find the slope of OP, which is 4 over 3, right? Rise over run is 4 over 3. In that case, slope of PQ will be negative 3 over 4. Is that clear? And we are given a point P, which is 3, 4. So straight away we can find equation of the line, right? So now let's work out the equation of tangent line. We are going to use the formula y equals to y minus y1 equals to m times x minus x1, correct? To get the answer in standard form. So what we get here is y minus point is 3, 4. So 4 equals to slope, which is minus 3 over 4 times x minus the x value is 3. Multiplying by 4, we get 4y minus 16 equals to minus 3x. Minus and minus is plus, correct? Bringing all the terms to the left side, we get 3x, and we already have plus 4y equals to 16 plus 9, which is 25, right? So option A is the right option. Do you see that? So we can easily solve such a question without doing much of what you learned in earlier classes, right? So concept helps, and that is very important. So when we are solving questions related to calculus, making a nice sketch and then thinking about a solution is a better approach than following any other thing, right? So I hope that helps. Let's take the last question now, which is based on piecewise functions. So in calculus, we work with a lot of piecewise functions, so it is also a very important concept. Question 10. F of x equals to kx minus 2 when x is less than or equal to 3 and x squared plus 1 when x is greater than 3. We need to figure out for what value of k is the function continuous, right? So let's try to sketch this function and then we'll try to figure it out. We are given x squared plus 1 when x is less than 3. Okay, so let's say this is the value for 3, right? So this is 1, this is 2, this is 3. So when it is on the left side of 3, it is a parabola. Now when it is on the right side of 3, it is a parabola which is x squared plus 1. So if I write 3 here, so 3 squared is 9 and we get 9 plus 1 as 10. Okay, so at 3, let us say this value is 10. Since it is greater than, I'll make a hole here, right? So it is not a fixed point, it's a hole. So basically x squared plus 1 is kind of a parabola which will be rising like this. So it is going to go up. If I write 4 here, 4 square is 16 and 1, 17. So the parabola is kind of going up here. So at 4, we may have a point which is, you can write this as 4 and 17. So this point here is 3 and 10, correct? So the y value here is 10. Now, so that is the second part when x is greater than 3. The first part is a line, right? So the first part here is a line with slope of k, y-intercept of minus 2. So somewhere here we have the y-intercept. To make it continuous, this line should actually go through that point, right? So basically we are looking for equation of a line which is kind of like this. Do you see that part? So this is at minus 2. So this is the concept. So the line should have the point 310 on it, correct? So from here it is clear that the value of the function at 3 should be equal to 10. Since if I put 3 here, I get 10, right? So since 3 squared plus 1 is basically 9 plus 1, which is 10. Does make sense to you? So that is what it is. So at f of x is actually equal to the linear function. So we'll write f of 3 equals to k times 3 minus 2. Now f of 3, as you see, should be equal to 10. So 10 equals to 3k minus 2. 12 equals to 3k. Or that gives you the value of k as 12 over 3, which is 4. So we get option B as the right option, correct? So the explanation for this is that both parts or both pieces are continuous, right? So we have a line here and we have a parabola. So both are continuous in their domain, right? So for f of x to be continuous, kx minus 2 should be equal to x squared plus 1 at x equals to 3, correct? So that is the condition which we exploited to find the value of k. Does make sense to you? So this goes well with most of the piecewise functions where we want to make them continuous, correct? Sketching a piecewise function is another huge part of prerequisites for calculus. So I'd like you to go through and review some of the questions based on that. With this, we come to an end of our set of 10 questions, which I feel are most important as a prerequisite skills for calculus. Feel free to write your comments, share my videos, and if you really like them and subscribe to them, that will be great. Also, practice a bit more on similar topics to really do well in calculus. I hope that helps. Thanks for watching and all the best.